Video key for quiz 2 for summer 2025. And again, I make these keys for two reasons. One, so that you can use these as a study tool and check yourself, but also I use this as a way to make sure there's nothing wrong with the answer key. So as I'm working through this, if I find anything that might be wrong, I will adjust it. Okay, so for the first question, this is nomenclature. For this quiz, the first three questions will use the same molecule. For this molecule, what is the parent chain? So the goal of this question was really to get you to break down the steps that I use for nomenclature, which is 1, identifying the parent chain. Then 2, identifying the substituents. And then 3, combining it all. So I try to walk through those steps so that you don't get too much off just like a nomenclature question, and kind of try to do what we call scaffolding on this. So when I'm looking for the parent chain, I'm looking for the longest continuous chain of carbons, and it looks like this to me. Now, I'm not trying to trick you or anything. Sometimes there will be like additional ones that you have to look out for that could be longer, and so you might have to branch, but in this case, we don't have that. So just the highlighted in green is the only one that I see, and so I'm going to number that. And I'm not paying attention to which direction I number at this point. I'm just trying to see how many carbons are in this chain, and it looks like 8. So the parent chain for this molecule is octane. So that's worth 1 point. If you notice the double bond and you went ahead and put octene, I'll accept that as well. And then if you put oct, but you put the wrong suffix other than one of those two, you'd get partial credit. Okay, and then the next question, we're using the same molecule. For this molecule, what are the two substituents? Include substituents, alkenes, alkynes, and other functional groups. So I said it that way because sometimes substituents are alkanes, and sometimes people don't count alkenes or alkynes as substituents. Sometimes they put them as part of the parent chain. So I explicitly wanted you to know that you need to include not only the alkenes, but also the alkynes. So I'll go ahead, and again, we have our parent chain here highlighted. And so anything outside of that parent chain would be considered a substituent here. So I see two substituents. One is this fluoro or fluorine. And if you put fluorine or fluoro, either one of those is fine. If you put halide, you'll get partial credit for that. And then over here, an alkene, or if you put an ene, or if you put double bond, you'll get credit for any of those as well. So each one of those was worth 1 point. Now for the final one, we're using the same molecule. For this molecule, give full proper name. Be sure to include cis or trans where appropriate. So that is kind of a hint. We have a double bond. You need to include cis or trans. But I'm going to just walk through the steps that I already talked about, which is 1, we, of course, try to identify the parent chain. I wanted that in green, just for consistency. So we already did that, and our parent chain is octane. So step 1, our parent chain is octane. I can write it in green. Step 1, we have octane. Step 2, we found our substituents, fluorine and alkene. So we have a fluorine and an alkene, but we do need to number those. And typically what I would do is number both directions. I like to use 2 different colors to see what each of them would end up being. So in this case, if we went with the dark blue numbering, we would get our alkene at 3 and our fluorine at 5. If we went with the purple numbering, we would get our fluorine at 4 and our alkene at 5. Okay, so that's a tough one, but overall, the alkene is 3 and then 5 versus 4 and 5. If you sum those together, 3 plus 5 is 8 versus 4 plus 5 being 9. So dark blue is better, but that's not the only reason that dark blue is better. The other is that alkene is a higher priority than the fluorine. So that's on that priority chart that I showed in class. So alkene being a higher priority means that we need to give it the lower number. It has priority on being a lower number than fluorine. So if all things are the same, we need to go with the alkene. So that's 2 reasons to start with the left side or use the dark blue numbering scheme. So now we know our step 1 and our step 2, and then the step 3 is combine it all. We combine it all in alphabetical order, and we look for any other prefixes, so that's where the cis or trans comes in. So I am going to start with my prefix, the fluorine, so 5-fluoro, and then you can say 5-fluoro-oct-3-ene, or you could say 5-fluoro-3-octene. Either of those is correct. The locant can either be right before the ene or right before the whole oct. Either one of those is fine. For me personally, I think it's least confusing if the locant is right before whatever the thing is, so I always put it right there. But we need to determine if this is cis or trans before we're done. So if I draw a line right through the middle here, I put my 2 hydrogens in. The hydrogens are on the same side, so this should be cis, 5-fluoro-3-octene, or cis, 5-fluoro-oct-3-ene. Either of those is correct. So for this, you'd get 1 point for including cis or trans correctly. You'd get half a point for each of these numbers, and you'd get half a point for each of your substituents being in the right place, so before or after, and that's how we get to 3 points. Okay, this next question is a matching type question. We're trying to find the relationship between each 2 atoms. So something that I think it helps to do is to draw everything in. So bromine, we'll start with you could either start with either everything pointing up, or you could start with everything axial or everything equatorial. Either of those is totally fine. But if I'm thinking of bromine, this bromine is axial and it's pointing up, which means that the next video, or the next, the next axial, it's an implied hydrogen, this would be equatorial pointing up. And then this fluorine now, again, up axial, the hydrogen on this fluorine, and then the hydrogen here would be up equatorial, up axial for this implied hydrogen, and then up equatorial. So now we've gone all around, and you can see that everything that's pointing up alternates. Axial, then equatorial, axial, then equatorial. So we have up axial, up equatorial, up axial, up equatorial, up axial, up equatorial. Now I'm going to do the same thing for the downs. So we have down equatorial. I'm going to draw this hydrogen in, down equatorial, and then this is down axial. Then down equatorial, and then we'd have a hydrogen here, down axial. And so when you're drawing your down equatorial and down axial, so when you're drawing yours, you need to make sure that this happens, down axial, that you get these same alternating things. And if you're not sure about this, I do have a video that would be very helpful on my playlist, mini lectures. And it's specifically on drawing cyclohexane and telling the difference between cis, trans, and axial equatorial, because they're not the same thing. So students want to say like, oh, this is axial and this is axial, so they must be cis. But that's not true. The cis or trans has to do with whether they're pointing up or down. So in this case, we have our Cl and our Br. So the chlorine is down, and the bromine is up. So if the chlorine is down and the bromine is up, then that must mean they are trans. Now I'll look at the Br and the H, and there are a lot of H's in here, so I actually, after the fact, I wrote in that the H we're looking at is the one that's drawn in, because there's a lot of implied hydrogens, but we're specifically looking at the H that's been drawn in. So the H that's been drawn in, we have bromine pointing up, and the H that's pointing in is pointed down. So again, these are trans. Now we look at this H and this F. One's axial and one's equatorial, but again, that's not what we care about. What we care about is which one of these are pointing down versus up. And these are both pointing down, so they're cis. And now we'll compare the fluorine and the chlorine. These are both equatorial, but that's not why they're cis. They're cis because they're both pointing down. So you should be able to kind of draw this in and process through this to tell what cis versus trans is. Either they're both pointing up, they're both pointing down for cis, or one's up, one's down for trans. And it's not about axial or equatorial. They're related, but they're not the same thing. Okay, I hope that was helpful for you, and good luck studying for your exam.